number can be factorized into primes in exactly one way carries over to this new number system. Now you have to expand your notion of what a prime is, because you've got now new numbers, so they may or may not be primes, and it could be that what used to be primes are no longer
¿Te
primes.
gusta el caballito, Constantín? ¿Te gusta? Sí.
What he also discovered was that if we adjoin other numbers instead, we might not get the same result. So for example, in this number system, this is just all the normal numbers, except that we now allow ourselves this one new number. So this one still is a number system, but it has the unfortunate property that it doesn't have unique factorization. So just to give you an example, in this number system, we have the number 6, which could be written as a product 2 times 3. But at the same time, it can be written as this. This is a problem because here we have one way to decompose it into a product of primes. Here we have another way, completely different, using completely different primes. It's not just a matter of rearranging the order.
So it worked for the square root of minus 1. It didn't work for the square root of minus 5. Where are we going here?
So what he observed was that it doesn't work for all numbers, but he did identify quite a few for which it did work. Specifically, he identified a list of them. We still do have to use factorization,
Like 30.
provided we choose one of the following
It's actually funny.
Well,
It's actually a horse. I was like, is this a donkey?
How long
No,
did
it's a
it
horse.
like that would be good for another year for him, right?
Yeah,
these are the numbers for which
a year,
we
2
get
years.
unique factorization. And then there's a big jump to this one.
So that one works.
And this one works. As you can tell, it's quite a bit removed from the previous one. And what Gauss conjectured was that this was the last one. That for some reason, with this number, the list stops. No matter what other number after this you add, you no longer have unique factorization. He conjectured that this was really the way it was, that it was true, but he could never actually prove it.
I can see why that number intrigued you now.
The problem is to try to actually show that this is the last number for which this happens, that this list is exhaustive, that there are no other numbers of this sort that one can add in order to get unique factorization in the new numbers.
Tough nut to crack then.
It was a very tough nut to crack. And what's interesting about this problem is that it was actually solved by what might be called an amateur mathematician, someone that wasn't officially a mathematician. So a German by the name of Igner actually found a proof in the 50s. And he did actually publish his result, but it wasn't accepted by the mathematical community for several years. And then in the 60s, by the name of Baker, an American,
But don't push him because he doesn't want to get in.
found other proofs which
Don't
were
push him, make him do it himself.
after a couple of years, one of those mathematicians
Okay, okay.
Why are you pushing like
went
this and
back
stuff?
to what Igner had done, analyzed
do
it
it.
in more
Let him figure it
detail,
out.
and realized, hold on a second, he did actually have a proof. It was actually okay, with just some minor issues.
So, and what did Hegner find? Was Gauss right?
He was right. This is the end of the list. And mysteriously,